Hi everybody, this is Joey Smith at the University of West Georgia. Welcome to my series of short how-to videos in forecasting. This video will explain the basics of how to use Excel to produce the simple exponential smoothing model. And so what we're going to start with is the same data set that we were using before. This data comes from the Energy Information Administration. The link for the Energy Information website that I got the data from is eia.gov/energy-explained/prices-and-outlook.php. Once you arrive at this site, you're going to see a graph that says the U.S. annual average regular grade gasoline prices from 1976 to 2021. In order to download this data, all you have to do is click on the little hamburger up here on the right-hand side at the top of the graph, and this will allow you to download the data as a comma-separated values file. So all you have to do is click here, click on Download Data, and it'll give you the option of downloading it as a comma-separated values file. This will open in Excel. Now I'm not going to open it again, but what you're going to want to do is immediately save that file as a regular Excel spreadsheet. The reason I say that is if you don't save it as an Excel spreadsheet, the formulas and the graphics that you produce will be lost if you save it as a CSV file. It doesn't support formulas in a CSV file or graphics. So make sure you save it as an Excel worksheet. Okay, so once you've downloaded the data, you're going to have basically these three columns: year, nominal price, and the real price. This is what downloads as part of that data series. I've put a lot of extra stuff in here for now, but this is primarily to get things started fairly quickly. So we're going to focus on the real price, and this is in January dollars. January 2020 dollars. So everything here is based on the most recent value of the dollar. Okay, and so 2020 is going to be the base year, and January is the base month for that year. I've got the formula for the simple exponential smoothing model already included as a graphic or as a cell in this spreadsheet, but you will not have that in your spreadsheet if you download it directly. But effectively what we're doing here is we're creating the forecast f sub t plus 1 is equal to alpha times x sub t plus 1 minus alpha times f sub t. Okay, so how do you do that in Excel? Well, if you see up here in the yellow box, I've gone ahead and put in our initialization value. And in this case, I just simply made the initialization value the same value as the 1976 actual real price per gallon of gasoline. Now, I could have used any number of different techniques to create that initialization value. And so it can change depending on what's required for your particular task. As I say down here, the initialization value is a best educated guess of our first value of f. But now, how do we create that second forecasted value? We can't guess at all of them. So the second value is going to be equal, and so this is f sub t plus 1. So f sub t plus 1 is equal to alpha, and here I've included alpha in J2. So alpha is 0.5, so equals 0.5 times, and it says over here x sub t, and so what's x sub t? Well, if this is f sub t plus 1, x sub t is the actual value in the previous period. And so that's the $2.79 that you see in column C. Plus 1 minus alpha, 1 minus alpha, times, make sure you include the asterisks for times there, because if you don't, it's going to give you something, but it won't be what you're looking for. So 1 minus alpha times f sub t. Well, if this is f sub t plus 1 in cell D8, then f sub t must be in cell D7. And so it's the previous forecasted value. When I hit enter, it gives me the new forecast. This is now f sub t plus 1 in cell D8, and f sub t is cell D7. Now they look identical, and there's a reason for that. It's because I use the same number for both our real price, our real x, and our f. It's the same number, so it doesn't matter what alpha is, it's going to give us back exactly the same number again. Okay, so how do we copy this formula down now? Well, we've got to do a little bit of house cleaning inside the formula. Remember, we're going to continuously use J2 all the way down the column. And so I'm just going to go ahead and lock that cell in for both my 1 minus alpha and my alpha by using those dollar signs in front of J and in front of 6. So it's $J, $6, and then in the 1 minus J6, it's 1 minus $J, $6. Click enter, and you see nothing changes in terms of that formula, but if I copy this down one cell, it now shows something a little bit different, but it still relies on that J6, and so we've locked the cell in successfully. But guess what does iterate? So when we move down one cell, our previous value of x moves down with it, and our previous value of f also moves down along with the formula. Okay, so now we can successfully copy this down. And remember, we can use that little closed square, that little solid square at the bottom right-hand side of your cell in order to copy this down all the way to the bottom. Okay, and so I've copied it all the way down to 2022. So we've got our forecast here. Make sure you go down here and check to see where this ends, because you want to create the forecast, but you also want to make sure that you don't go all the way to the bottom of the spreadsheet. Okay, so I'm going to go ahead and go through the errors as well. So how do we calculate the errors here? Remember, it's just the actual value, which is our x column, minus the forecasted value, which is our forecasted column. And so x is contained in column C, and our forecast is contained in column D. And so let's start off by calculating the error for the first value that we actually produce a real honest-to-goodness forecast for. So that equals C8 minus D8. And so there's our first error. Now, why don't I calculate an error for this at the top in C7 and D7? Well, this is convention, but you don't usually include this as part of your error calculation because I made this number up based on the actual value of x. And so that error is going to be 0 by construction or by definition. And so I control that error. And so I don't want to include that as part of the evaluation of this particular model. Some do, some don't. I'm one of those people that doesn't include that. And so now we've got that error calculated, so we can copy this error all the way to the bottom. Double clicking copies it all the way to the bottom. But guess what? It creates an error down here where we do not have an actual. And so we need to get rid of that one. So that last error where we've got a forecasted value but we don't have an actual value, we've got to remove that from our error calculation. What about our absolute error? Well, the easiest way to do that is say equal ABS, open parentheses, and then select our error. As long as we've calculated our error correctly, our absolute error will also be calculated correctly. and we copy that down. Now we go down and look and get rid of that last 0, the one that we weren't supposed to have because we don't have an actual value. We've only got a forecasted value. What about squared error? We can just take our error and raise it to the second power. And so this gives us our squared error for this forecasting model. Double click, go down, get rid of that extraneous error that we shouldn't calculate. And so now we've got all of our errors, all of our absolute errors, all of our squared errors calculated. So now if we wanted to calculate our mean error, so this would be mean error. The next one would be mean absolute error. And this would be mean squared error. And so all we need to do is say equals average of all of those errors, and that gives us our mean error. And so this is the mean error, negative 0.00831. Our mean absolute error, we actually don't have to go back and calculate this again. We can just copy this over. And so this gives us our mean absolute error. You can see that it's the average of those as well. And the same thing is true with mean squared error. We can just copy that over. And so this gives us the mean squared error for that column. Now we don't have another forecast to compare this with right now, but this gives us the start of a comparison when we develop another forecast. Okay, so we've calculated the mean error, mean absolute error, and mean squared error. So how do we calculate root mean squared error, RMSE? Well, that's easy now. All we have to do is take the square root of the mean squared error, and that gives us the root mean squared error. So there's 4 measures that we calculated in just a small amount of time. Okay, so is this the best that we can do with this forecast? Well, maybe, maybe not. If you use the technique that I show you here, where alpha is in a cell, then in order to change alpha for all of these calculations, all we need to do is change it in one location. So suppose we were to change this from 0.5 to 0.6, and we try to see whether or not this improved our measures of error down here. Let's focus on root mean squared error. So it's 0.442479. Okay? So we're going to go up here and change this to 0.6. When we hit enter, it recalculates all these values, and this drops to 0.419 from 0.44. So we actually improve the model by changing alpha. Let's change alpha to 0.7. That reduces our root mean squared error yet again, meaning that larger values of alpha, things closer to 1 and farther from 0, seem to be giving us better values of the root mean squared error. And so we're improving the model by changing alpha. Now again, I said later on we're going to talk about using solver in Excel in order to optimize. We're not there yet, but that will be in the near future. Okay, so what have we done here? We've calculated a simple exponential smoothing model. We've calculated several measures of error, and we've optimized to a certain extent using different values of alpha so that we can get the best forecast we possibly can. Now, we haven't totally optimized this yet, but we've started down that process. Remember, work these problems out, work out these examples, and if you have problems, send me an email. Thanks, everybody.